Good day, students. This is Ademola Johnson, your chemistry and biology tutor. Please don't forget to share this video, like it, and subscribe. Press the subscription button. Don't forget in the part 5 video we talked about the methods of preparing a standard solution. And we said that there are two methods. The first one is gravimetric method, and the second one is dilution method. Now, what is dilution? Dilution means the addition of water. Dilution means the addition of water to a liquid or an aqueous solute or aqueous solution in order to reduce its concentration. So don't forget, if water is being added to a solution, the concentration will be reduced. Just like you put 4 cubes of sugar inside the water, a glass of water, and by the time you increase the volume of water, you add another cup of water, you discover that solution will not be as sweet as it used to be before, because the concentration of the sugar has been reduced as you add that. Now, look at this. Dilution formula can be used to determine the amount of water to be used to dilute any solution of known concentration, known molar concentration. So there's a formula that is guiding us. When we want to dilute, we don't just dilute, we don't just add water. That formula is called dilution formula. Now, the dilution formula is given as C1 V1 equals to C2 V2. Our C1 is what? Initial concentration. Of the solution. While V1 is the initial volume. While C2 is final concentration. While V2 is final volume. Now, if you have a question like this, now let's look at likely questions on this. Examples. You can say, find the volume of distilled water required to dilute 10 cm³ of 0.03 mole per dm³ HCl into 0.01 mole per dm³. So you are asked to find the volume of distilled water required to to dilute 10 cm cube of this, so that the concentration is no longer 0.03, the concentration is now what, 0.1 mole per dm. What is the volume of water we are going to add to it? Then it can be asked also, hence, find the dilution factor. Find the dilution factor. So what are we going to do here? Now, write out your parameter. C1 is the initial concentration, which is what? 0.03 mole per dm cube. Then V1 is the initial volume, which is 10 cm cube. In fact, you can write, then your C2, after dilution, the concentration is now 0.01 mole per dm cube. Then your V2 is unknown. Now, that is the new volume. So that's that. This is your initial. This. So what do we do? Your formula is C1, V1 equals to C2, V2. Now we are looking for V2. So V2 equals to C1, V1 over what? C2. So your V2 now will now be, what is our C1? 0.03 times what our V1? 10 over, what's our C2? 0.01. Our V2 now will now be equal to what? We have 0.03 times 10, then divided by 0.01. Answer is 30. cm cube. Now what we have got in here, the final volume of the solution after dilution is the 30 cm cube we have just gotten. That's the 30 cm cube we have just gotten. Now, the volume of the water added will now be 30 minus what? 10 cm cube. So answer is now what? 20 cm cube. So 20 cm cube have been added to 10 cm cube to get the 30 cm cube here. Then what is dilution factor? What is dilution factor? Now, you are asked to find the dilution factor. Now, what is dilution factor? Now, what is dilution factor? You are asked to find the dilution factor. What is dilution factor? Dilution factor is the number of times the solution is diluted. The number of times it is diluted. And there are two formulas to that. Now, dilution factor is equal to C1 over C2. So we also have dilution factor is also equal to now V2 over V1. You can see here now, 1 is up, 2 is down here, but here now 2 is up, 1 is down. So what do we do? Here, using the first one, method 1, your C1 is what? Your C1 is what? Is 0.03 mole per dm cube. And your C2 is what? 0.01 mole per dm cube. So your dilution factor which is C1 over C2 will now be C1 as 0.03 over 0.01, and answer is what? Is 3. So show it has no units. This means that then use method 2. Dilution factor is equal to V what? V2 over V1. What is your V2? Our V2 is what? Is 20. Is 30. While our V1 is 10. So that is what? 10 here 1, 10 here 3. It's also 3. It means that the solution will be diluted 3 times its original concentration. Now, method 1 shows that the solution has been diluted 3 times its initial concentration. Then method 2 shows that is method 1. It shows that 3 times the amount of water added to the solution is 3 times higher, or sorry, they find the amount of the solution, the amount of the solution after dilution, the amount of the solution after dilution is 3 times higher than its initial volume. So that is that about dilution method. So in the next video, we are now going to look at stoichiometry of chemical reactions. Stoichiometry of chemical reactions. So where we are going to look at, we will be given a question where from which we are going to derive an equation, and from there we will now begin to solve. That's where we will now look at various relationships like mass to mass relationship, mass volume relationship, mole relationship, mass mole relationship, and so on and so forth. So now we will continue there. Please, I will admonish you to watch out for the next video where we are going to do that. So see you then. Don't forget to share this video, to subscribe, and to like it. See you next time. I remain Afe Ademola Johnson. God bless you, and bye for now. Thank you.